Hello, guys. So, can you guys see my screen? All right.
Yeah.
So, yeah, we can go ahead.
All right. Hey everyone, I'm William from Parallel Processing. So this is our project. So basically we built an AI supported credit card fraud detection machine. And basically you can check out our product spec with that button over there. It basically lists our MVP and details. And I shall pass this on to um
Right.
Ray.
Okay, so for our process, the first thing we did was understand our data set using Python and Pandas and other visualization libraries to conduct EDA. Then we started cleaning up our data set and finding correlations between the 6 features and our target variable. And then we started coding machine learning models. We trained on 10 different classification models using the scikit-learn library. And I'll pass this on to Engoron.
All right. For the features that we use for the predictions, we use six. The amount of the transaction, the old balance originals, the new balance origin, and old balance destination, new balance destination, and the type of transaction. And further, for our EDA, we use libraries such as pandas. We use pandas to essentially read in our data set into a data frame so we can manipulate it and so we can like hold the features that we want for model learning. And next we have Plotly, which you use for multiple visualizations to represent like different columns in our data set to understand what we're actually working with. And I'll pass it back to Ray.
And for visualizations, we have 9 total visualizations, a few scatter plots, histogram, and heat maps, pie charts, and box plots.
So, our models one of the models we made was a support vector model. And this model is actually really popular because it uses a classification approach and it also helps separate different classes. The overall objective of this model is to segregate any data set into a hyperplane and then fit it with a line in between the different classes while having the highest margin. Next, Kanan.
So next we have K nearest neighbors, which is a supervised machine learning algorithm that predicts like similarity between like the new data, so our X test inputs, and the available data that we train our model on, so X train and Y train. And it can be used for like regression and classification, but in our case, we use it for binary classification to classify a new input based on the Euclidean distance from all our different feature points.
The random forest classification is a machine learning model which creates decision trees on selected data, collects a prediction from each tree, and then selects the prediction with the most votes as a final prediction. We used a line of code from sklearn.ensemble import random forest classifier to create our model. Our hyperparameter n estimators equals 2 in this model because the accuracy remained the same when we had more than 2 n estimators. After training our model, we got an accuracy score of 0.99989. To visualize the performance of our classification algorithm, we made a confusion matrix and a classification report, which also reflects our high accuracy score.
XGBoost or extreme gradient boosting is pretty similar to random forests, except that it, instead of using bagging, uses boosting to help make its prediction sequentially across a number of different decision trees. You import it using that code, and from there, it works in somewhat of a cyclic way, creating weak learners that acts as a classifier based off of the original data, and then residual models, which act as predictor models based off of the test data, and then it creates new models, adding them together using a loss function. And in gradient boosting and XG boosting, we use a gradient function to attempt to minimize this loss function, where then we would have the highest accuracy. XGBoost is really accurate, and we found that it was one of our highest accuracy models that we use, probably because it did the best across multiple trials. We had an accuracy score of 0.9998, precision score of 1, and especially worth noting is its really high recall. Another reason why it might have been just a little bit ahead of some of our other models was the range of customization that we get with hyperparameter tuning, because it has so many more hyperparameters that we are able to tune to exactly what we need them to be than a lot of other models do. And then in addition to that, we did logistic regression as well, which was particularly useful for us because we found that the sigmoid function just was a very nice way of sorting everything together, even without doing anything. So that was our least amount of editing that we needed to do to get to 99% accuracy.
We also used the naive Bayes classification models, more specifically the Gaussian naive Bayes, where we basically would take the probability of the given class labels and then using that, find the likelihood probability, which can also be called the prior probability of each attribute, which we then plug into the Bayes formula, or which is derived from the Bayes theorem. And with that, we find the highest posterior probability as a result of that from each classification. And basically what we got out of each model was that we saw how random forest classification and XGBoost were the most accurate, with XGBoost boasting an accuracy score of 0.99825 and a ROC-OX score, or ROC-AUC, of 0.928. The model yielded only 3 false negatives, 18 true negatives, 17,204 true positives, and 0 false positives, while the random forest classification had an accuracy score of around 0.9989, along with a ROC-OX score of 0.972197, and the model yielded 19,996 true positives, 1 false positive, 17 true negatives, and 1 false negatives. I'll take this off to Shruti.
In general, many of these top machine learning models yielded very similar results with extremely high accuracies, but random forest and XGBoost performed the best. For next steps, we would like to do further research into this topic and hope that our model can be used for real-world problems dealing with payment fraud, and we would also like to create better models with a larger and more balanced data set.
So our hardworking team includes me, Asad Shahid, who's the technical expert and the GitHub enjoyer. And we have...
Hi, I'm Engoron. I'm the decision maker and debugger.
I'm Jayden. I'm the designer and project manager.
I'm Ray. I'm a front-end developer and design helper.
I'm Shruti Vora, and I data dissection.
I'm William. I'm the communications. I discuss the proposals. I kept the agenda in check, and I'm the organizer, and I made the code clean.
I'm Katherine. I'm their instructor, and I'm also uncertified Cal academic advisor. I just want to give a shout out to my team because they did a really good job these past 2 weeks, and I love you all very much. That is it. Thank you.